Hello guys, welcome to HVAC Solutions. In this video, I am going to show you how to do HVAC heat load calculation by using E20 sheet. So guys, this is the E20 sheet. So this is our school building location located at Bangalore. Today we are going to do heat load calculation for the classroom G14. Okay guys, please note it down. Here length and width of the room is 19.810 means 20, and width is 17.65 means 18. 20 means 20 is the length and width is 18, and window glass area is 5.9 by 4 feet. You can take approximately 6 by 4 feet, yani means 24 feet, and the our glass is exposed to sun in the south direction. This is south direction. Okay, south direction. And weight of the building is 80 lb per square feet, and ceiling height is 10 feet. Okay, so length 20 feet. First is project name, school building. This is area, classroom name is G14. Length is 20 feet, width is 18 feet. You will get, if you multiply by 18 into 20, you will get 360 square feet. Height is 10 feet. If you multiply these two values, you will get 3600 cubic feet. Okay, and next is latitude, altitude, daily range, outside air and inside air temperature. We have to take from data book. So this is the outside design condition for Indian cities. So our location is at Bangalore. Yes, okay, yeah, Bangalore. Outside design condition for Indian cities. Location is Bangalore. For Bangalore, latitude is 12.6, daily range is 22, altitude is 921, and this is the outside temperature. For school building, you have to take this area, means 93.2 as a dry bulb, and wet bulb is 67.3. Okay, for school building you have to take this value, 93.2 is a dry bulb temperature and 67.3 is a wet bulb temperature. Latitude 12.6, altitude 921, daily range 22, and outside air temperature is 93.2. Dry bulb, sorry, for outside air dry bulb is 93.2 and wet bulb is 67.3. And by using psychometric chart, you will get the value for relative humidity and humidity ratio. One second, I will show you. See, this is a psychometric chart Excel sheet. You have to put dry bulb 93.2 and wet bulb 67.3, and altitude is, one second, altitude is 921. Okay, so you will get these values. Relative humidity is 26.4, you can take 27, and humidity ratio is 63.6 grades per LB, you can take 64. See, relative humidity is 27 and humidity ratio is 64. Okay, and this is the inside room. For inside room, you have to take constant value. For dry bulb, you have to take 75, and relative humidity you have to take constant value, that is 50%. By using these two values with the help of psychometric chart, you will get the value for wet bulb and humidity ratio. Okay, one second. For dry bulb, you have to use this one. For dry bulb, dry bulb is 75, and relative humidity is 50. So you will get this value. Wet pulp is 62.43. You can take 63, and humidity ratio is 64.65. You can take 65. Wet pulp 63, humidity ratio is 65. If you take the difference, you will get this value: 93.2 minus 75, 18.2, here 4.3, here minus 23, here minus 1. Okay. And next is solar gain through glass. See, our window is exposing to sun in the south direction, so south, and our window area is 24 square feet. 1 second. See here, 5.9 by 4. You can take 6 by 4, 24 square feet. So 24 square feet. And so again we have to check the data book. Our Bangalore latitude is 12.6, so we have to check for 12.6. Here 0 is there, 10 is there, and 20 is there. So 12.2, 12.6 is not there, so we have to go for IL value, that is 20. In this 20 north latitude, we have to check for this month, maximum temperature month, between July 23 and May 21. Okay, and our window is exposing to sun in south direction, so we have to check the value in south. Here we have to take the highest value. For south, highest value is 14. Okay, so you have to take 14 is the solar heat gain to glass. So solar gain is 14, and solar factor it's remain constant 0.78. If you multiply, you will get this value 262.08. Okay, next is outside air. You will get automatically here this 360 square feet, 20 into 18, 360 square feet. You will get automatically. In our office, total people 25 people are there, so you have to put here 25, and for square feet and CFM per square feet and CFM person, we have to take from data book. See, we have to check here minimum ventilation rates in breathing zone. Okay, so our area is office. So office space. Okay, here okay. No, sorry, here this 25 people, our location is classroom. Our G14 is classroom. Okay, so classroom 25 people are there, 25 people, and CFM per person and CFM per square feet we have to take from data book. Here minimum ventilation rates in breathing zone. So our location is classroom, and children's age is between 5 to 8. In this area we have to check here people air outside outdoor air rate and air outdoor air rate. Okay, CFM per person is for class room age between 5 to 8, 10, and CFM per feet square is 0.12. Okay, so we have to take this value. Here CFM per person is 10 and CFM per square feet is 0.12. If you multiply 360 into 0.12, you will get this value if you multiply you will get this value. So you will get CFM 293.2. So outside here is finished. Next is infiltration. You will get automatically from here value 20 into 18, that is 360 into 10, 3600 cubic feet. And here we have only one wall is exposed to sun. This is air change per hour. So if we have only one wall is exposed to sun, you have to air change per hour is 0.25 for summer. If two wall is exposed to sun, we have to take this value 0.5. In our case we have only one wall is exposed, we have to take here 0.25 value. Okay, so air change per hour is 0.25. if you multiply you will get this one. So net outside air is 278.2. you will get automatically by E20 sheet. Okay, next is transmission gain through wall and roof. So here we have only one wall is exposed to sun, that is in south direction. Okay, and we have to take these values. 1 second. See, for south direction the width is 20 feet. Okay, 20 into we have to multiply with true height. False ceiling height is 10 feet and true height is 13 feet. So 20 into 30 20 into 30 260 minus we have to subtract glass area 260 minus 24. 1 second. 260 minus 24, so you will get 236. One second guys. Sorry guys, here 18, so width is 18, we are calculating for this area. Okay, so 18 into 2 height is 10 feet and false ceiling height is 10 feet, 2 height is 13 feet, we have to multiply with 13, so 234 minus we have to subtract 24 because we already calculated glass area, that is 24 feet minus 24, so you will get 210. Okay, so here 210. Next is equivalent temperature difference, that I will show from data book. So here this is the equivalent temperature difference. See, our medium weight building is 80 lb per square feet. Okay, so here weight of the wall 80, ours is south direction, our wall is exposed to sun in south direction, we have to check for this area. Okay, so here 80 is not there, so what we have to do, we have to take the highest value in the 60 60 go and highest value in the 100 and we will get the average. Here 60 we have to take the highest value, that is 26, and 100 you have to take the highest value, means 66 16. 26 plus 16 is 42, divided by 2 21, means 100 by 60 160, divided by 2 80. For 80 we will get 21, means 26 plus 16 is equal to 42 divided by 2, means 21. So equivalent temperature difference is 21. Suppose if the building weight is 100, you have to take directly the 100, the highest value is 18, you have to take 18, okay, like that. So here we will take the average 26 plus 16, 42 divided by 2, 21. Plus this we have to add correction factor. See, our temperature difference is outside and inside is 18.2. So here 18.2 is not there, this is the temperature difference, so we have to go for higher value, that is 20. And daily rate for Bangalore is 22. For 20 we have to intersect the 22, daily rate 22. If you intersect this value by this value, you will get 4. So correction factor is 4. So you have to add this value to our equivalent temperature difference, that is 21. 21 plus 4 is equal to 25. So you will get 25, okay. And next is U value. Guys, you will get the U value from the civil department people. If you not get from civil people, you have to take the standard U value, okay. Guys, please note down. For external wall, U value is 0.089, and for roof U value is 0.063, and for partition U value is 0.487, and for typical floor U value is 0.358, okay. So here we have external wall, so U value is 0.089 as per standard. If you multiply these three values, you will get this value 467.25, okay. So transmission gain through walls and roof is completed. Next is transmission gain through other. All glasses you will get automatically from here 24, and temperature difference is here 18.2. And for U value for glass you have to take from data book. See here typical fenestration characteristics, okay. Our glass is fixed and made up of material aluminum, so we have to take U value, this value 1.13, okay. So U value is 1.13. If you multiply you will get this value. Next is non-AC partition glass. We don't have non-AC partition glass, leave it as it is. Next is non-AC partitions. Here we are calculating this area G14, okay. This area we already calculated, okay. This area is AC, we are calculating for non-AC partition. So this area non-AC, this area storeroom also non-AC. So this area is this area width is 18 feet. So we have to calculate 18, we have to multiply 18 into 2 head, that is 13 feet. 18 into 13 plus this area non-AC 20 into 13, okay. One second. See here this area non-AC, so 20, you take 20 feet, 20 into 2 head 13, so 260, and this area is also non-AC. So 18 into 2 height is 13, 234 plus we got here 260. So you get 494 total. Okay. So 494 is the non-AC partition area. And for non-AC flow, ours is ground floor below that non-AC partition, below this non-AC area. So you have to take this value 360. Okay. Just 360. Next is temperature difference 18.2, and here you have to subtract -5. Outside to inside is there is -5 degree, where there is a difference between 5 degrees. So for that reason you have to subtract 5. 18.2 minus 5, 13.2, 18.2 minus 5, 13.2. Okay. If you put 20, to take automatically 50-50 like that. Okay. Here 18.2. So minus 5, 13.2 like that, like this. And for U value for non-AC partition, I already shown you that is 0.48. For non-AC flow is 0.36. If you multiply, you will get this value. Okay. Transformation again to other is completed. Next is internal heat, nothing but sensible heat. So here people 25 people are there. And here first one is B2 per hour. We have to take from design book. See here, heat gain from people, we have to take this value. Office, hotel, apartments, we don't have classroom, we take this value. Office, hotel, apartment. Sensible heat is B2 per hour is for 245, and latent heat B2 per hour is 155. Guys, please note down. So here 245. If you multiply, you will get this value. Next is lights. Here lighting power density, ours is classroom. Here LPD watt per feet square is 1.4. So we have to multiply our room area with this value, means our room area into 1.4. One second. Our room area is 360 square feet into 1.4. So you get 504. So 504 watts. Okay. Next is, this is ballistic factor, this constant 1.25. This conversion factor, this also remains constant 3.41. If you multiply, you will get this value. Next is appliances. Actually you will get from electrical department. If you not get, you take approximately for classroom 1000 watts. 1000 watts. And here this is usage factor 0.75. This conversion factor remains constant. If you multiply, you will get this value. Okay. So total sensible heat is 17736.088. Okay. Next is, and we have to add safety factor 0.1. Safety factor is 0.1. So 0.1 into this value, you will get this value. And our effective sensible heat is 19509.6967. You will get automatically in E20 sheets. Okay. Next is latent heat. People 25, and B2 for latent heat is 155. If you multiply, you get this value. Next is infiltration. Infiltration is 15. So 15. And next is after B2 here humidity ratio difference. Our humidity ratio difference is after BTU, it is humidity ratio difference. First is here BTU, so BTU I mentioned. Next is humidity ratio difference, that is -1. So -1. This conversion factor, it remains constant. If you multiply, you will get this value. And bypassed outside egg, you will get automatically 278.2 from here. Okay, net outside egg. This also humidity gain difference, humidity ratio difference -1. This conversion factor 0.68. This ballistic factor, balance factor 0.1. If you multiply, you get this value. So total room latent heat is 3845.8824. And you have to add safety factor. So you have to 7 by 100 into, we have to do it 7 by 100 into this value f what means here 3845. You will get 7 by 100 into f45. You will get this value. Okay, 1 second. By 100, okay, into f45, here this 3845. So you will get 269.21. Approximately you will get 270 safety factor. Okay, and effective room latent heat. So here this value and this value. So you will get this value, you will get this value. Effective room latent heat. Next is effective room total heat. Is this one. Effective room latent heat plus effective room total heat. You will get this value. Okay. Next is outside air heat. Here sensible heat and latent heat. So you have to mention here CFM, bypass outside air. Both are same 278.2, 278.2. And first one is for sensible heat, we have to mention the temperature difference, that is 18.2. And for latent heat, you have to take humidity ratio difference, that is -1. This conversion factor 1 remains constant. For sensible heat, conversion factor is 1.08. If you multiply, you will get this value. And for latent heat is conversion factor is 0.68. And here 1 minus balance factor. So 1 minus balance factor, you will get this value. And total outside heat is 4751.21088. You have to add safety factor, you have to multiply with 0.05. You will get this value. So one safety factor, you had here safety factor. If you multiply 0.05 into this value 4751, you will get this value. Next is effective heat, effective outside heat. So you will get automatically, and grand total heat is 2861.613.5623. This also you will get automatically after entering the value. So our total ton of refrigeration is 2.3845 ton. Okay. Next is effective sensible heat factor and ADP, apparatus dew point. So effective sensible heat factor is equal to effective sensible heat divided by effective latent heat. Guys, you need not you need not to worry, you will get automatically by E20 sheet. Okay. See, effective sensible heat factor is equal to effective sensible heat divided by effective latent heat. 19509, this is effective sensible heat, and 23624.7905, this is effective total heat. So if you divide this value, you will get automatically 0.82. So our effective sensible heat factor is 0.82. For this ESHF, we have to select apparatus dew point, that is from data book. This is the apparatus dew point. So our inside dry bulb temperature is, that is constant 75, and relative humidity is 50. So we got ESHF 0.82. So here ESHF. So we don't have here 0.82, so we have to go for a higher value, that is 0.84. So for 0.84, apparatus dew point is 52. Okay. So apparatus dew point is 52. And dehumidification area is 20.7, dehumidified quantity 872.683. Okay. You will get automatically these values. So ton of refrigeration is 2.3845 ton, approximately 2.4 ton. Okay. So guys, this completes our HVAC heat load calculation for the room G14 by using E20 sheet. If you like the video, please share and subscribe. Okay guys, thank you.